Okay, so this is our day 2 for this webinar workshop on quantitative research methods and statistical analysis for quantitative research. And so today is 11th of December 2022, and we are recording this webinar workshop for the purpose of uh, reviewing by those who may have intermittent connectivity in Zoom. So, so recap, so we are done last time with a review of the quantitative research concepts that we need for this, for our discussion. And a big part of the quantitative statistical analysis, which includes the measures of central tendency and the measures of dispersion. So there is still another measure of location. There are only 3 measures. Wait, excuse me. So for the univariate data analysis, we have 3 measures. The measures of central tendency, dispersion, and location. So it is today that I'm going to show you a recorded video lecture on the measures of location. Okay. So this is important for your univariate data analysis because you are going to present your variables in either in a table format or a graph format, but then you are going to reflect on the table or on the graphs the frequency and the percentage as to how many, for example, have the age of 20, how many are 21, and so on. From your sample. So you are going to describe your sample using the frequency, how many, and then the percentage, how many percent is, for example, 20 people who belong to 20 years old, how many percent is that? Okay. And then you'll have a corresponding workshop for the measures of location. And it's also in the Google form. And we're going to proceed to the sampling, parametric sampling. And after parametric sampling, we will proceed to the bivariate data analysis. Okay, now the bivariate data analysis, we are going to have the correlations and the t-tests. So there will be 4 exercises for today or workshop that something that you are going to work on for today. So let's start with, let me pull out the video on on the measures of location. Measures of location. Wait a while. Where is it? location. Okay, but while I'm pulling out the video on measures of location, if you have questions with regards to last week's topics, you may ask. You may type in or you may speak for your questions if you have. Do I take it that no question or no question? Very good, no? If you have even questions with regards to, you have plans for your research later. Is this your first semester?
For me, this is my first semester. When I rewatched the video, hindi ko naman siya natapos. I remember you were my sociology 1 professor way back in my undergrad. I remember Ma'am Mary and Faler. So sabi ko, hindi ko matandaan si Ma'am Nadaklan. Ma'am Faler. Yung pala, si Ma'am Faler, may sociology 1 professor. Then,
I'm sure what the family name that you have now is also not the family name before.
yes, my married name, my maiden is Akak, Lucille Akak.
Yeah, because when I look at you, you also look familiar actually. So when was that? 2000 what? When?
2001, 2002, I hardly remember. Basta mga ganung,
I just came back from Lasal that year. Maybe not, yeah, Faller, no? So not pregnant yet. Okay, nice to see you again, Lucille. So I've already pulled out. So there's no question for our last meeting, but you are really free to ask questions that I can answer because we will only be meeting until today. So let me share the screen for this. We're coming up with the measures of location.
This is Module 5, Univar.
I've not shared the sound yet, so share sound. Automatic din.
my
This
sound
is Module 5, Univariate Data. Descriptive analysis using measures of location. This comes after we have discussed measures of central tendency and measures of dispersion. This time, this is about data analysis of large sample, where before we are done with the small samples. So large sample is that composed of more than 30 pieces of data. So compute the three measures of central tendency, dispersion, and location. Now, the measures of location used to locate the position of a piece of data relative to the rest of the data. There are two measures of location, quartiles and percentiles. These are considered to be the two most popular measures of location. Quartiles are numbers that divide the rank data into quarters. So if you quarter uh, a peso, you have 4.25 cents. Percentiles, numbers that divide the set of data into 100 equal parts. So let's label the quarters into Q1, Q2, Q3, Q4. So Q1, exactly the same 1/4 of the data, is smaller than itself. Q2 is exactly the same as the median, therefore it's called the median. So for the 1 peso, it's a 50 centavos. Q3, exactly 3/4 of the data is smaller than itself. Suppose this is the raw data with this labeled rows 1 to 10, and these are the 50 pieces of data. Sample size that comes from a population of admission test scores. So you see this raw data of 50 cases are not arranged. But then the first that you're going to do is place the data in order from the smallest to the largest, hence giving you this rank data from 27 to 128. So just arrange it from lowest to highest. Now with this rank data, we now obtain the measures of central tendency, obtaining the mean, median, mode, mid-quartile, and mid-range. The measures of dispersion, that's range, variance, and standard deviation. And the range measures of location, which could be quartile or percentile. There are 50 pieces of data and 1/4 of that is 12.5. So therefore Q1 would be halfway between the 12th and the 13th pieces of data from the smallest. Like this. Q1 would be equal to this, and Q3 would be halfway between the 37th and 30th pieces of data. It looks like this. In detail, from the rank data, you're going to identify where is the location of the 12th and the 13th. So here and here. Then in the equation, Q1 is equals to these two numbers. Divide by 2 and you get 71. On the other hand, Q3 is halfway between the 37th and 30th pieces of data. So this first column here, 10, 20, 30. So 30th would be this, and 39th would be this. And in that equation here, 97 plus 97 divided by 2 equals 97. So Q3 is 97, Q1 is 71. Now the entire set of 50 pieces of data would not present much of a picture to the reader of a report. So we need to classify the data into categories. And this allows to represent the situation pictorially as well as help with the calculations for the remaining descriptive statistics. There are three basic guidelines for subdivision into classes. First, 5 to 12 classes. That's most desirable, not below, not more than. Each class must be of the same width. Classes must be set up so that each piece of data belongs to exactly one class. So from this rank data, first identify high and low scores. So we can see the high and low scores here, 128 and 27. So and find the range. Range is just to subtract highest minus lowest. 128 minus 7 is 101. That's the range. Next, select number of classes and class width that covers the range. There could be 10 classes of 11 will cover 110 units. It may look like this. Okay. Those were 10 classes. Pick a starting point. Suppose that we start at 22. Counting from there by 11s, we have 22, 33, 44, 55, and so on. Like this here. And this would be the lower class limits. These figures, which actually the smallest piece of data that could go into each class. So 32, 43, 54, that would become the upper class limits, which are the largest value fitting into each class. So you see these are now 10 classes. First class, second class, third, and so on. 10 classes with equal width, okay? So the resulting class limits would look like this. So you now plot those on this table with these row labels with the corresponding class limits and the tallies from the rank data. So there is one from the rank data, remember, and there is one for this class limit and so on with the frequency, corresponding frequency. Okay, so actually this is very easily done using the frequency counts using the computer software AXL or the SPSS. So let's just stop here for this particular topic.
Okay, so small sample and large sample, no, it's important for you to remember that when you are dealing with quantitative method, you should have large sample. It should be beyond 30 for you to use uh, percentage. If your sample is below 30, you may not use percentage, just use frequency. Most qualitative researches will just will be able to use frequency and sufficiently, no need for percentage. And just for the purpose of review as well as evaluation, no, for that particular topic on measures of location, this is the percentage. Let us have this very simple to do. Something to do. This it's a workshop. So I'm going to put here the link to the Google form. So you now see the link for the Google form for the frequency and percentage. So particularly, it's percentage. So please access the form and answer. Because it's Google form, so that there will be immediate feedback. You are going to deal with multiple choice. It's like a board exam, and because you will not take anymore the board exam, but for the purposes of immediate checking.
to use Microsoft Excel in the computation of the measures of central tendency, of dispersion, and of location for our large data would just be first to copy and paste those data here on the sheet. This particular sheet we are going to rename as COVID-19 because these are COVID-19 data. Reported cases and deaths by country, territory, or conveyance. We call this as a whole areas as of December 14, 2020. So these are composed of columns and rows. Every row contains data for that particular area. So for example, this row here, row 4, it's about the data of the world's total cases, total new cases, total deaths, new deaths, total recovered, new recovered, active cases are critical, total cases per 1 million population, total deaths per 1 million population, and okay, the population of the world, that's over 7 billion actually. So all of those in that row are about the world. All of those in row 5 are all about the USA. Okay. And then all about this column C is about total cases. And for column L, that's all about deaths in every 1 million population. Okay, so copy pasted. Now let's see, I've already written here what we need to do in this exercise and this demonstration. So we have here an N, or to represent the sample. How many are all the areas included here in this data set? Then we need to identify the first area. Where is the first area located? And the last area. Okay, and then all these computations that we need to do for the 3 measures. So the total N, let's have scroll down to have the total. So we have all in all 220 areas. Okay, and these are actually arranged according to the highest towards lowest. So the N here is 220. The first area is in row 5. Row 5. Okay, and the last area would be 224. Located at row 224. Okay, so arrange according to rank. Where's Philippines? Let us see. Philippines is ranked number 28 in terms of COVID cases. Let's now go to work. The mean. Okay, I just encoded that. Mean equals to, and the answer should be here. Place your cursor here and click FX. This is insert function. Okay, let's choose average because that is what mean is, average. Okay, you may do this. We are going to compute about total cases, so we are going to use the data on the C. The total cases, suppose you can have actually you can do this, scroll down and so on, but you can also type like C5, that's in column 5, row 5, in that column, up to C224, because we know that the last area is in 224. Okay, so in seconds it's there. That is our mean total cases, 327,000. Median, the same FX, but we choose median. Okay, from C5 to C224. Yes, and that's the median. You see the big difference between the median and the mean? This is the middle. The median is the middle of the rank cases. Now that's the measures of central tendency. Let's go to dispersion, variance. Function, variance. That is the variance. Okay. The variance, we are going to use the data here in the deaths. That's in column L. So L5 to L224. Okay. So that's the variance now. Let's just have this color to differentiate. Oh, standard deviation function. Standard deviation, okay. L5 to L224. Okay, that's the standard deviation. See how fast you can do this? And last is the percentile, the measure of location of the USA total cases in relation to worldwide cases. So how many percent is this 16 million from out of the 72 million total cases in the world? Okay. Aside from doing that, the previous ones I've shown you about, you can also directly encode here equals sum, no, equals sum, and then open parenthesis, USA is in C5. C5, we divide that with the worlds, that's in C4, close parenthesis, and then we multiply afterward with 100. That's how you are going to obtain the percentile, right? Okay, enter. So you now have this 22.95, or if you are going to round off that later, that would become 23%. And that's all about using Microsoft Excel in the computation.
Okay, so I hope you're able to edit your exercise if you think that you needed to. So let's proceed. Okay, any question with regards to that, by the way?
Parang ang bilis niya po, ma'am, pero kung may instruction naman sa computation, madali na lang siguro. I mean, just like the other session na merong ano po, parang may instruction on how to
That's why I remember that in the previous exercise, they were all plotted already, that you only need to put in the required values. But in this exercise, it's sort of raw. So I need to show you that video telling you with the instructions on how you are going to use the Microsoft Excel in computation. But it's you who will, because it's kind of raw, so you'll be the one to, I mean, yeah, tapos i-encode kasi yung, but how did you finish your exercise? Because you already have, most of you already have submitted even before I've because you need to key in, I think, this rank data, no? Let me, and then lang kasi I think if you're opening your Google form, the exercise 06, diba, you have 50 sample size, and that you are going to rank the data, and on the rank data, those are 50 that you need to encode pala. So, nakuha nyo kaya yan? Okay, balik sa recording. This one. Let's have a look at this exercise. Measures of location. So the question on it is univariate analysis when, okay, A, you compute for the mean and median of the variable numbers of years in school. Yes. You compute for the standard deviation of the variable income. So answer is C because both are correct. And then next. Are you with me? Hello.
Yes, ma'am.
Sige. So number 2, it is still a univariate analysis when you analyze the small sample, because this is the Morse type, no, wherein there are only two answer choice. There are two choices, A and B, but four possible answers, no. A when A is correct, B when B is correct, C when both A and B are correct, and when D when both are not correct. So it is still a univariate analysis when you analyze the small sample, yes. Analyze the large sample, yes, because you are going to have the univariate analysis first in every research that you are going to do, whether small sample or large sample. Now, next is sample is representative of a population. A large sample can be A is 30 cases and below. Of course, that is just a small sample. So more than 30 cases, yes. So B is correct. And 4, when presenting the data, A, obtain both frequency and percentage for a small sample. Obtain both frequency and percentage for large sample. So the answer is B, which is obtain both frequency and percentage for large sample. Because as I mentioned a while ago, if it's a small sample, you don't need the percentage. So you just have frequency for that. Number 5, a distribution is aptly named as. So both A and B are correct. So if you only deal with frequency, you name the table frequency distribution, comma, responsive status, if frequency only. But if both, so you are going to mention both frequency and percentage distribution, responsive status. So both are correct. So a number 6, aside from the frequency count, a large sample of 50 cases can be applied with the calculations of measures of location, percentile, or percentage. So both are correct, because when it's a large sample, you are going to have the measures of location, and that is percentage. And that number 7, measures of location include range, variance, standard deviation, mean, median, mode, reduce, and mode quartile. And what is the answer? Both A and B are not correct, because the measure of location is percentage. And these are measures of dispersion. The letter A is for measures of dispersion. The letter B is the measures of central tendency. So number 8, quartiles are a number that divide the rank data into quarters, yes. Numbers that divide the set of data into 100 equal parts, no. So the answer is A. Number 9, This quarter is exactly the same as the median, therefore called the median. And that is Q2. Because if there are 100, Q1 is 25, Q2 is 50, Q3 is 75. So the median of 100 is 50, so which is same to Q2. Now, for this species of data, this one, raw is arranged to become rank data. This is the choices are first step, first step, first step. So it's a first step to arrange the raw data into rank. That is the first step. For this pieces of data, the mean from either the raw data or the rank data is because either way, your answer should be the same. The choices are 84.1, 88.2, 86.8, 80.5, and the correct is 80.5. What is that? Let's look at the answer key. So the answer key, okay, as per formula of the mean, you add all of the cases and divide by the total number of cases. When you add all of the cases, the total is 4,025. You divide that by 50 because you have 50 cases in that sample. So the result will be 80.5. So the mean is 80.5. That's it. I hope you got that correct. Number 12. For this basis of data, the mode from either of the raw or the rank data is, so we have the choices, 84 and 94, none. Both A and B are correct, so the correct answer is none. For the pieces of data, the first quartile is 54, B 65, B SC 59.5. And what is the explanation to that? Okay, the first quartile or Q1 is halfway between the 12th and 13th pieces of data from the smallest. So for the given rank data, the 12th is 54 and the 13th is 65. So Q1 is equal to 54 plus 65 divided by 2 is equals to 119 divided by 2 equals 59.5. So Q1 is 59.5. So 12th and 13th rank, no? 12 and 13. That is here. So 10, manino, 10, 11, 12. This is 12, this is 13. So 54 and 65. Okay, so for this pieces of data, the percentile of the three pieces of number 84. So the answer choices are 3%, 6%, 30%, 60%. So 6%, or our explanation to that for that is there are three pieces of number 84. So that's what the question was. Divide 3 divided by 50 is equals to 0.6. So 0.6 multiplied by 100. Then so the percentile for the three numbers is percent. Of the variables included in your class survey, I mean, it's an example that you are doing a class survey. What cannot be done for the variable age if your sample is below 30? I mean, this word class survey here can refer to any research that you are doing. So what cannot be done for the variable age if your sample is below 30? So A, frequency count can be obtained. Yes. Percentage can be obtained. No. That's not what you can do. That cannot be done. So again, that's a repetition of what we already know, that if it's below 30, you don't need to calculate the percentage. Okay, so let us now proceed. Are we good with that? Are you good with your results? So, i-close na natin ang exercise na ito, no? Lock it. And let's proceed to the next topic, which is the use of table of random numbers. So we're going to discuss actually the parametric sampling, which is what you need to know in your conduct of quantitative research. So again, I have a video lecture for this, so I'm just going to share with you the video lecture. And don't you worry, the next exercise will be very, very simple. And so let me now pull out and share the video lecture on the parametric sampling methods. Here it is.
To continue on sampling, Module 9 focus on parametric sampling methods. Previously, the question, how many respondents shall compose the study sample? That's already answered in the previous module. And the sample size already determined through these two steps. First, the study population or universe you already have defined, and the sample calculated already using a sampling formula. It is at this point when the appropriate sampling method is decided. Now, sampling methods can be non-probability sampling, especially for those qualitative studies, or probability sampling for us in this course, which is focused on quantitative methods or research method. So we have under probability sampling, simple random, stratified random, systematic, cluster, and multi-stage. We are going to take this one by one. Now, probability sampling, all members of the population have an equal chance of being selected in the sample. The fundamental idea here is that there is provision of useful descriptions of the total population. A sample of individuals from a population must contain essentially the same variations that exist in the population. That's why we call the sample a representative of the population. Now, the uses of probability sampling is when researchers want precise statistical descriptions of large populations. Example of large population voters, young adults from 14 years old to 25 years old, reproductive mothers, age 15 to 45 years old. For large-scale surveys. And also probability sampling is can serve as basis for developing of policies that affect large populations, like company policies or government laws. Let's take first the simple random sampling. This is widely used, wherein every element of the population has an equal chance to be selected as a source of data. So it's like a lottery type selection where every source of object is identified by means of a tag placed in a container. and the tags are thoroughly mixed and drawn. May use the table of random numbers, which we will take late in a while. Now, stratified random sampling is used when there is already list of the universe whose members are classified into certain categories, like the category of students, there are faculty, and there are staff, as in the case of MSU constituents. The procedure would be to get a list of the universe, decide on the sampling size or the actual percentage of the universe that should be considered as sample. Get an equal proportion of sample from each group. Remember, you already have determined the number of the sample from your calculation using the sampling formula. Example, suppose there are 200 students, 300 faculty members, and 500 staff. Okay? Now, you're going to have, this is the population, no? From the 1,000, you're going to have a sample of 100. So in proportion, you are going to have an equal of 10% from each of the category, and thereby you'll have 20 from 200 students, 30 from 300 faculty members, 50 from 500 staff. From the 100 respondents, either by simple random sampling selection or systematic sampling. Now, what is systematic random sampling? Used when there is already list of the total universe or population. It is a functional equivalent of simple random sampling and usually easier to do. For example, get a list of the total universe or population. Divide it by the desired sample size to get the sampling interval. So, if the total population is 5,000 and the desired sample is 100, just an example, you're going to divide 5,000 by 100. So you have 50 as sampling interval. So get number 50 as the first sample, and every 50th person in the list would be the next to constitute the sample. So 50 is the first in the sample, followed by 100 person, the 150th person, the 200th person, and so on, until you reach 100 respondents out of the 5,000. So that is systematic random sampling. Also, if you're going to consider subdivision, for example, you are going to have 5 as the sampling interval. So every 5th house in the particular subdivision will be your household sample. Cluster sampling, used when there is an area where the results of several surveys on certain issues virtually match national results. The procedure would be, natural groups as clusters are sampled initially, with the members of each selected group being sub-sampled afterward. For example, students from Philippine colleges and universities. First, select a sample of Philippine colleges and universities from a directory. Then, get list of the students at all the selected schools. Third, draw samples of students from each of the school. The multi-stage sampling involves repeating of 2 basic steps, listing and sampling. Lists of primary sampling units, for like churches or blocks in subdivisions, is compiled and may be stratified for sampling. A sample of units is selected. The selected primary sampling units are then listed and may be stratified. The list of secondary sampling units is then sampled. For example, a population area of a city. First stage is you select a sample of blocks. Second stage, you list the households on each selected block. The third stage, you now obtain sample households. The fourth stage, list the people residing in each household. The fifth stage is to obtain sample persons within each selected household. That's the multi-stage sampling. Now, these different sampling methods that we have mentioned, simple random, stratified random, the systematic, the cluster, and the multi-stage sampling, you can combine them depending on which may be appropriate to the study. Now, using the table of random numbers, to recall, you have first determined your sample size through a formula, then decided the appropriate sampling method for your research. In the selection of the actual sample, the table of random numbers can be useful. Suppose you want to select a simple random sample of 100 people out of a population totaling 890. Remember, the population is just 890. Now, suppose this is the table of random numbers. Actually, there are so many versions of the table of random numbers. We're going to use this version. So you see, the table is composed of rows, and columns. There are 30 rows and there are 32 columns. Okay, suppose you are going to say, look at column 5, row 8. Column 5, row 8. So the number is 5. Okay. Now we are going to say, look at column 28, number 5. So the number is 0. Okay, let's now begin. Step 1. Number the members of the population from 1 to 890. Remember, the population is up to 890. Not necessary if you have them in a list that clearly totals to 890. Now, second, determine the number of digits you'll need in the random numbers you select. For 890 population, you need 3 digits or 3 columns because each of the column here has 1 digit only. So you select 100 random numbers in the range from 001 to 890. Now, third, refer to the table of random numbers. This one, create 3-digit numbers from the 3 columns because you need 3 columns, right? Follow a pattern in moving through the table to select numbers. Decide where to start. So you follow a pattern like going downwards or going upwards. Make a plan and stick with it. Sample plan. Use the rightmost 3 digits in each case. So you go right. Choose numbers all the way down the column until 100 cases are selected. Okay, this is the plan. You go right and then choose numbers downwards. Action. Close your eyes and stick a pencil into the table and start where the pencil point lands. And this is really what you are going to do as a researcher. Now, suppose it landed on row 7. Row 7, row 7. This is row 7. Okay. Of column 6. Row 7 of column 6. Okay. So what's the number? The first digit is 1. Okay. And using the next 2 right digits, 0 and 4. Because you remember the plan, you go right. Okay. For 3 digits, you just need to determine the first digit. Then you go right and choose the next 2 digits to have 3 digits. So you now have 104. So the first
sample unit is 104. Going down, the next sample units will be 820. Skip those bigger than 890. So 104. So since the next number digits are 996, these are not included because we only have 890 population. So there is no more after 890. So the next to 104 would be 820. Continue downwards until you reach the desired total sample, which is 100. Remember to skip the numbers that are bigger than the population. So the next would be 519, 869, 417, 200. Going down. So we have 19, 617, 759, 714. And we have these next digits. So 216, 516, 103, 697.
The video has ended. So 890 as a sample. No, that's a population. We are getting only how many sample as a sample? 10, for example, no? So beyond the 890, you should skip. Well, and then stick to plan. Like you just need, these are columns, no? These are columns and these are rows. So this is the 6th column and this is the 7th row. And that is the digit, the first digit for the first sample case, 104. No. Because you stick to plan that you are going to just use for the particular column block, because these are by blocks. So suppose these are by blocks, so per block there are 4 columns, and in that particular block you are going to use the rightmost 3 digits. So that's why it's 104. But if you are going to have in your plan that you are going to use the leftmost digits, and so the number would be 910, but then that is beyond 890 as our population, so 910 will not be included. Okay, do you have any question here? Before we're going to have the exercise. Okay, I will send to you now the file for that exercise. File attached from computer, and it's this file. It's a Word file. Oh, click to retrieve. Ayaw man. Why? This IO error? Ano naman to? Cannot be sent because it is currently in use. Sige, oy, ana di ay. Ayan. So I will open again. I just sent you. Please open that particular file. I sent to you, and let's go over this file. So let me share screen so that we will see together. We'll see at the same time the file that you need to work on. Share screen. Okay. So worksheets are up. Have you already opened the file? Your file? Okay, so I assume now that everybody's opened the file, and we are on the same page. And this is page 1 of the 2 pages. Suppose the population is 1,120, and these are board examinees. Using the table of random numbers below, you are tasked to select the first random sample size of 12. State in detail your plan and action. So, of course, you are going to have a plan. What's your plan? The plan is, what's the plan? The plan is to have what? There are 4 columns, di ba? This is the table of random numbers. There are 4 columns in each block. So you're going to include all of the 4. So that's easy. So that's what you are going to say in the plan. Of which you are going to encode your plan to the Google form, which means to say that I need to attach now the Google form in a while. So whatever you are going to write here, you just paste on the Google form that will attach in a while. So that's your plan. Include all the 4 columns in a block. I mean, close your eyes, no? You include that. So this is really what we do, no? In quantitative research, we are going to employ table of random numbers. So you include in the plan, close eyes and stick a pencil on the or your fingertip on the screen na lang because that random numbers table is on the screen. And then you are going to say that, okay, you use the whole of the 4 columns. Or actually, if your finger land on suppose land on the column 7, row 5, so that's number 2, number 2, and you're going to use for the rightmost or the leftmost 4 columns. So kung rightmost sa plan, so it will be 2555, and that is a big number. And then, so that's not included. So here, 17, and it's also a big number. Okay, next is 493. Okay, that's included. Next is 95. No, that's big. Next is 2. I think you'll have difficulty if you're going to say that. You may say in your plan that you are just going to include 3 columns. You may have that 3 columns or 4 columns going left, 4 columns going right. It depends on what you are going to say on your plan. As action dito, no? Plan is to use how many columns, right or left, and then the action is you close your eyes and the fingertip landed on what column row, and that's your starting point for the choices of your sample cases. Do you have any question? Are we in the same page? Just to test, yeah, if we're in the same page, if you cannot say it, just write it on the chat box. What number? So I'm going to ask now, just to test whether we are on the same page. What is that number if my fingertip would land on column 20, row 7? What is the number? Please type on the chat box. Column 20, row 7. Sige daw. So, okay, you said 7, 7, 7, okay. So 7, yes.
Tama na kun kanap teluwing ta pia pandikom niyan.
So we are assuming
Matiblay
that,
ka pa sa didiyan ta kulay.
wait, may nakalusot. May nakalusot na sound. Anyway, so we are assuming, no, that everybody's okay. Assuming that everybody's on the answer is number 7. So, last na lang ito na paano. Sige na, tingnan natin. So, sila yung hindi nakatype ng answer nila. What if my fingertip landed on column 25, row 25? So, what is the number? Column 25, row 25. And what is the number?
Hindi namin makita ang row 25 na, ma'am.
Hindi ba makita?
Hanggang 23, yan. Okay, better po.
Sa'yo lang yata kasi yung iba nakakita. Okay, so, okay, if it is number 1, what should be the number for our first sample case if we are going to use 4 columns? So can you type in the number? What should be the number combination using the left 4 columns if are the fingertip 25, column 25, 25. Column 25 and row 25, and you are going to key in the ISO 9700. Okay, remember that so dapat paano tayo, no? Pabaligtad ito. So it should be 1007 dapat. Okay, kuha ninyo 1007. If you're going to say you're using the leftmost, so where your fingertip landed, that should be the first number. So you go left, so pag ganun siya, 1007. But if you decide to say, to use the right, so it should be what? Sige daw, i-type nyo daw. Or if you're going to say you are going to use the right. Okay, correct. 1566. So if you use the right numbers, you go right, it should be 1566. If you go left, it should be 1007. Okay. So last na lang ito kasi para makuha na talaga natin, no? What if last na? Okay. So what if your fingertip landed on column 10, row 15? Column 10, row 15. So what is the number? So it's number 6. So what if we are going to decide to use three digits going left? What's the number? 3 digits going left. Okay. Then what if you decide to use 3 digits going right? Okay, so correct. So 3 digits going left, 649. 3 digits going right, 672. Okay, very good. You're ready for your exercise. And the exercise is just according to you, according to your plan, and according to your action. So I will just attach here the Google form. Sige, pwede nyo nang gawin ngayon. Tapos, whatever you come up with, you just attach, you just copy paste on the Google form. And wala siyang score agad-agad kasi manual checking ito. Hindi siya nakaset because iba-iba yung answer nyo because it's according to your plan. So, yun ang plan, no? Ikaw nang bahala. Anong gamitin mo? How many columns? And going right ba or going left? Yun ang sa plan mo. And then sa action, where will your fingertip land? What column and what row? Kasi that's how we're going to check if what you do is correct. Sabihin mo na, the fingertip landed on column blank, column this and row this. And yun na, malaman natin kung correct yung ginawa mo or hindi. Kasi you have the starting point specified. Okay. So the Google form is now here. Okay, so I will need to send again the file, because if you got out of the Zoom and you got in again, you will not anymore see the file. So it's now sent successfully. Please tell me if okay means feel yes if you got the file. Yeah, it's okay. So laban lang. Okay, so you now have both, you now have the file and you have the link, so you can work on it and let's see if you got it. So I'm going to look into what you have submitted in the Google form. We'll check if you did right. So I've already edited the setting for this particular exercise on Google form, so that you can edit your answer. Yan. So this is what I meant, no? So the plan is randomly select column and row. Yun, no? Kulang. Kulang ito na plan. You should specify how many columns i-choose mo. How many columns only? And then whether you are going left or going right. Actually, you can go up, you can go down with, in your choosing. Now, state the location or your first digit. So, column 5, row 10, go left up to 12 digits. So, parang ano ito, i-edit mo na lang. Write your 12 sample here, separated by a comma. Hindi ito pwede ha. Because of 7, 7, 7, 8, 8. Bumalik-balik. Bakit bumalik-balik ito? Because you only use one digit. And you need 12. You need 12 cases for your sample na 12, di ba? Ang ilang number lang naman ang one digit? 9 lang. 1 to 9, di ba? Kaya, you will not be able to satisfy the requirement of 12. Kahit ubusin mo na ang 1 to 9, kulang ka pa rin. At saka, hindi na naging random sampling yan because, di ba? Bakit nagkumpul-kumpul ang mga respondents mo from 1 to 9? You have 1,120 population. Paano na yung mga nasa 800? Hindi na ba sila masali? Ang mga nasa 700? O, di ba? So, that's the idea here in sampling. You give everyone the chance to be part of the sample. You give everyone the chance to be selected. So that is how random and how heterogeneous your sample will be. And we said that sample is a representative of the population. So yan. So paki-edit na lang ito ha, kasi talagang wala itong kung ano. You need to really edit. Kahit sinabi mo niya you did well, I will say na you don't. Okay? So, but mabuti na rin yung positive tayo. So, let's go to the next Ay, hindi. Stop share muna ako para makita yung pangalan. Wait lang. Let's go to the next somebody. Next submission. Okay. Okay, so share again the screen so that we can know if we are right or not. So this work, okay? Sinabi, I've already mentioned kanina para kung kanino to, no? Kasi correct naman. Use 3 columns to the right, sabi niya, and then downwards. So, klaro. Very few words, but on point. Action. Close eyes and point finger on screen. The fingertip landed in column 13 and row 11. Ay, wait. Sana yung aking kopya. I-open ko muna yung file because makita niyo itong pag-open ko ng file. Ayan. So, ang sabi niya, ano yung sabi? Column 13, row 11. Tingnan nga natin. Column 13, row 11 is 7. And sinabi naman niya, yes, 7. So, going right downwards daw siya, di ba? Kaya, 7. 13, 11, then 7. 13, 11, going right. 7, 8, 7, 2, 7, 2. So, let us see. Ano ba yan? Ito kasali. Okay. Ano nga natin to para makita na lang ang both. Yan. Nakita niyo ba yan? Kasi gusto kong makita rin ang table of random numbers. So, I've arranged the screen. Mayroon na naman lumabas na account. So, kanino pa yan? But anyway. Okay, I've shown to you. Okay, nakita nyo na, no? Both table run of random numbers and the answer of this. So, kasi sa row 13 and 11 tayo. So, 7, no? 7, 8, 7. Yes, correct. Going downwards. Going downwards. Pero bakit hindi? Ang sunod dapat nito is...
Ma'am, ag-copy-paste ron ako sa ako ang kuan good ma'am katong Google. Wala din siya naka-arrange pag-paste na ko dire. Actually, na 272 after 2, ma'am.
So, wala ang 272?
Naa, ma'am. Sa answer, bali, nag-skip siya og 787, 740 ang 272 after 254 na akong answer.
So, wala din here. It's not here.
Yeah,
on the
ma'am.
Google form. Okay, so...
Nasa
anyway,
form, ma'am.
Nasa form? Ito lang yung nakikita. Nasa, may next pa ba?
Ika-7 na sample, ma'am.
Because I cannot... Ayan. Sige. 272, yun ang sunod dapat, no? And then 743.
Yes, ma'am. Sorry.
743, 588, okay, 374. Ayan na, okay, so you are on the right track. Pwede rin kasing going up if ever, no? So, stop share muna because I'd like to see, correct naman yun. Let's see the next submission. Ano naman? Okay, what's your plan? Ay, sige. Share screen ulit. Okay. Ano daw yung plan is, ano to? Column 5 and row 10. Include 12 columns. Going right up to 12. May pag-sure di. Sa include 12 columns. How many billion na siguro ni. Oy, ipa-edit. Editan ninyo ni be. You edit this one. And that is, the plan is just, yeah, to include column, yes. Pero do not yet, kani sa action na ning column 5 and row 10, sa action na ning butang. Started with number 7. Tapos ang, what? 7, ano to? 7, okay. Parang parehas ito sa first submission na pang tag 1 digit lang. Okay? So stop share muna kasi punta tayo sa next submission. O, see? That's the third. Oy, ano mo please? Ay. Parang that's the same. Ay, pagka pala mag-edit ka. Oh, so it's not true. Hindi pala ito edit. Parang ulit another response. Sige, if you are if you are submitting the edited file, tapos naging dalawa na pakalakas yung submission mo. So, the submission that you had, resubmission that you had, hindi pa rin yun siya, ha? You just edited the plan, but the result ay hindi pa rin siya correct. Let's go to this submission that is, okay, ibang kasi yun pala, may submission kang isa. So, naging dalawa na yung submission mo. And, you need to resubmit. Edit. Okay. Let us have this submission. The plan. Use rightmost 3 digits to the right or 3 columns to the right. Okay. Choose the combination of digits all the way down and then to update. Okay. And then action. Close eyes, move the pen randomly within the table of random numbers for 3 seconds. For 3 seconds. Very specific that you close your eyes for 3 seconds. Okay, begin with a combination where the first digit that the arrow points at actual is stop. Column 11, row 17. So starting digit is 5. Okay, let's see. Column 11. Column 11 and then row. This is column 11, row 17. 5, indeed 5. So you are going right, di ba? So, ano na? 5, 5, ay, wait. 5, 5, 6. Saan na yun? Nawala po. Ang sabi mo nga, column 11, row 17. Column 11, row 17. Ito ang column 11. Row 17, 5, 5, 6. Okay, 5, 5, 6. Then 9, 5, 2, yes. 2, 5, 2, 6, 4, yes. 6, 9, 2. Okay. So, okay, correct. and so on. Okay. Separated by a comma, separated by, sige na nga, separated by space. Tama naman ang yung ginawa. And then yes, you did well in this exercise. Okay, stop share. Okay. So, I would like to, yung second na na-edit, hanapin ko muna kung yung kanyang third na edit ay correct na, no? Sige, hanapin ko yung trabaho mo. Kung tama na, I'll pass by others, assuming na na-correct na kayo. Ito. Third, okay. Select where. Hello, malaking ano natin dito. Issue natin. This is your third submission ha, pero para maintindihan na lang kung bakit mali pa rin ito. Okay. This is your resubmission 2, no? Baga, kung sa ethics na submission, parang version 3 na ito ha. But bakit? Select 12 columns going right. Hindi talaga tayo nagkaintindihan. No? Start with column 5, row 10. Okay na yan. Pero itong sabi mo na select 12 columns going right, no. 3 columns lang siguro or 4 columns. Ang sagot mo ay ganun pa rin, no? So, wait, magkailang version ka ba talaga nito? So, ano na lang, how many times ka ba nag-edit? Paki-PM na lang ako. Meron ka pa bang last edit? Na-edit? Anyway, ano mo na lang, review the whole thing, this recorded video, so that you will do right afterwards. Tingnan ko lang yung iba, I may not necessarily shift. Tingnan ko lang kung use 3 columns to the left, then move upper. Oh, move upper naman sa kanya. Column 10, row 15. Okay, I think you are right on this. Okay, ang sunod naman, 3 columns to the left and going downwards. Okay. Tama naman ang action. Okay. Parang tama naman ito. Okay, submission number 10. Column 17, row 5. Okay. Going downwards, 3 columns. Walang nag-4 columns, ha? O, ito na naman bakit 12? Choose 12 column going to the right. Ibang submission ito, ha? Pero hindi pwedeng 12 column. Start column 5, row 5. Ay. Oh, parehas talaga ito sa work ng submission number 1, submission number 3 na naman siya. No. Please, PM kita, no? DM ka lang. Hanapin ko muna kita. Please. Because you already have the link and the one, you can do this later. We'll continue to the next topic. No, na-PM kita, no, na ikaw ay kailangan mong mag-submit. And tingnan ko lang yung iba. Kung hindi kita ma-PM, okay ka na. Okay? A-DM pa lang. Ito siya. Okay, correct. Submission 14. Wow, okay ito hindi. Akala ko you are using four columns. So if you're just writing the zero before your three columns, so you have the four columns in all. Okay, so well done to the majority of you. But the two that I DM'd, please resubmit. As I'm going to check this and put the rating, so you'll have 12 over 12, something like that. And because I give the Excel result of this to Professor Norm. So let's continue. And as I've mentioned at the onset, after the sampling, we are going to proceed to the bivariate. When you say bivariate, it's now the time that we are going to look for the relationship between two variables. If we look for relationship between more than two variables, that will be multivariate. We will not reach that far. We will just be up to bivariate in a way that will do for master's thesis. Now, the bivariate, you look into the relationship between two variables. Like, for example, age. Does age has any relationship with your attitude over something, or income? Also, another example. Age has something to do with income. Yeah, and you want to explore, or you want to find out if there is a relationship between the two, age and education. So independent variable is age, and the dependent variable is income or education or attitude. Okay, but of course, common sense will tell us that age has something to do with education. Like if you are 7 years old, naturally you have low education. But if you are 30 years old, you have higher education compared to the 7 years old. Okay? But attitude, there will be many other factors that are at play when it comes to attitude, not just age. Sige. Let me share with you the video lecture on the bivariate analysis using correlations, person correlations. So I'm going to access now the video lecture on that. Bivariate analysis.
Module 10 is on bivariate data analysis. After you have done your univariate data analysis, you have already presented one by one the individual variables involved in your study. It's time to proceed to bivariate to find out if there is a significant relationship in any of the dependent and independent variables. So this is focused on Pearson R correlation. There are four areas that may influence choice of analysis, and you can determine by asking the following questions. What is the level of measurement? Remember, Noir? Are the data paired? Are they parametric? What are you looking for? Differences, correlation, etc. So each of these four we are going to tackle one by one in the next slides. What is the level of measurement? You let us mention again these four levels. So these are arranged according to level. So this is the lowest level and this is the highest level. So ratio has the characteristics of those that below it. And so with interval and ordinal, the nominal has the most basic characteristics. So ratio and interval are continuous variables. You remember continuous variables? They are quantifiable. Ordinal and nominal are categorical or more on qualitative variables. The importance in knowing this is to make decisions about the type of statistical analysis that should be performed in your study. as arranged according to power, according to level. So nominal here labeled as same or not, like male or female. That's the lowest level of measurement. Going ordinal, that's higher than nominal, so it has the characteristic of nominal. It is also labeled, but rank this time. Example, second floor. So second floor is higher than the first floor, and so on. Interval higher than the ordinal, so it share the characteristics of both. It's labeled, it's ranked, and it's range. For example, a favor of 39 to 41 degrees centigrade range. Ratio, the highest of them all, is labeled, ranked, range, and zero. There is true 0 point. Like the 24-month-old baby, it's about age. So age starts at 0, same as weight and height. Are your data paired? Paired data are often the result of before and after situations. Before and after treatment, for example. Here, each research subject would have a pair of measurements. Look for a difference in these measurements to show an improvement due to the treatment. So before, weights of 30 children. Then, you introduce a month-long free feeding at a barangay health station where these children are going to eat feeding health, nutritious food for 1 month. Then you obtain the weight there after a month. So you already have, each respondent would have a pair of readings of weight before this treatment and after the treatment. This would be paired data. And we can name this for our purposes of computation. Before is X and after is Y. Are your data parametric? Ranks, scores, categories generally are non-parametric data. Measurements that come from a population that is normally distributed can usually be treated as parametric if it's normally distributed. Are you looking for differences or correlation? You have two sets of data. It may not always be a sensible thing to do, but you can do it. That there is a set of paired data, just like the example we had last slide. Look for correlation. Two sets of data where each data point in the first set has a partner in the second, like the weight of child 1 before and after, and so on. Consider these 2 points. Does paracetamol lower temperature? So you see here paired information. Does the number of exercises performed affect the amount of increase in muscle strength? Here, there are two variables involved. One, paracetamol, this, temperature. Now, the question is, does paracetamol lower temperature? Here, number of exercises is a variable, and then muscle strength is another variable. So what does this number of exercises do with muscle strength? Which of this is about a difference and which is on correlation? The first, about seeing difference. Does this drug make a difference? Because does it lower temperature? The second, about correlation. Does the amount of exercise correlate with muscle strength? As you do more exercise, do you have more muscle strength? Bivariate data, we already mentioned, involve two variables paired together for analysis. Educational attainment, for example, is the first variable. Another variable is income. Are these two variables related? How? Like, does educational attainment in any way affect income? The relationships here are not cause and effect relationships. They only predict the behavior of one variable from the knowledge of the other variable. Illustration. First, as a person grows taller, it is expected that he will gain weight. Is there a relationship between height and weight? Second illustration. Students are constantly spending their time studying and taking exams while going to school. Is it true that the more you study, the higher your grade will be? So imagine this bivariate pairing, so two variables. Next illustration. Research doctors test new drugs, like the COVID-19 vaccine, old ones too, by prescribing different amounts of and observing the responses of their patients. Does the amount of drug prescribed determine the amount of recovery time needed by the patient? Okay, so the linear correlation, does an increase in the value of one variable cause a change in the average value of the other? Pearson correlation coefficient, represented by letter R, can take a range of values from +1 to -1. So therefore, there's in between that is point. A value of 0 indicates no association between the two variables. That's the result of the computation. A value greater than 0 indicates a positive association. Okay, like this one. If you are going to plot the two variables with the values, it will look like this for positive correlation. It will look like this for negative correlation. And if no correlation, it's as scattered as this. So there is somehow a formation of the values represented by these dots, the x-axis and the y-axis. Correlation will be considered high when it is close to +1 or close to -1, and low when it is close to 0, like this. So if R is 0.7, looks like that, 0.3 like this, 0 like that. Okay, -3, there is a relationship but negative, so it will go like this. Going down, that is negative. Negative, but there is a relationship that is inverse. So if the correlation coefficients, the results of computations will be from 0.9 to 1, that will be considered very highly correlated. 0.7 to 0.9, highly correlated. 0.5 to 0.7, moderately correlated. 0.3 to 0.5, low correlation. Less than 0.3, have little if any correlation. So this will be after you have computed everything and you will have this values or results. So this is how you are going to interpret. 5 assumptions of Pearson's are: the variables must be either interval or ratio measurements. Okay. The variables must be approximately normally distributed. Do first a testing for normality. The species will actually do this. There is a linear relationship between the two variables. And outliers kept to a minimum or removed when you see them. It will look like this. This is an outlier. You can remove. Homoscedasticity of data. It will be like this. Variances along the line of best fit remain similar as you move along the line. So the formula for Pearson R will be like this. It's a series of x's and y's. So n here, we know that n is for sample. So summation of xy, summation of x, summation of y. And there is this summation of x square and the summation of x and then you square, and so on. What does a positive value for r mean? A negative value, a value of 0. As x increases and the value of y increases, r value will be positive. Okay. The positive value of r, for example, age and height of children. As a children grows older, the height will also be taller. So that is positive or a parallel relationship. So both will go up. It's still positive parallel relationship even if both will go down as long as the two variables will have the same direction. The negative value of r, age of automobile, as car ages, its value decreases. So there is opposite direction of relationship. It is inverse. So the value of that is negative. Okay. So given X is years in school and Y is tolerance score. Suppose these are the values of X and these are the values of Y. The N is 10. So each of the respondent will have X and Y values. So you are going to total this, total, and then you multiply X by Y, you put the product here, then x square, put here, y square, put here. So this is how you are going to do it efficiently in a manual manner. You remember when we computed the variance? So we do this and it will be faster. Okay, so already computed. 2 times 3, that's 6. 2 square, that's 4. 3 square, that's 9, and so on. And then you have the total here. And it's time to transpose. Okay, in the formula. So we already know that summation of xy, it's here. Summation of xy, you just copy. So n is 10 and 675. Summation of x is 79. Summation of y is 72. And then 10. The n is 10. Summation of x is square. We have value 761. Just put it there very fast. And then summation of x, that is 79 square, and so on. Okay. Then you follow IMDAS. First you multiply this. You have 750. You multiply the 2, 5688. And below you also multiply this. You have this. 79 square, you have this, and so on. To continue, you have now 1062 over this one, values of this. You continue, you're going to have multiply this with the, and you have this result in a million, over a million. And you obtain the square root of this. You have 1202. And now it's time to divide the final step. 1062 divided by this, and you have the value of r, which is 0.88. And where is that in the, if you're going to remember, recall the interpretation that will have a high correlation, right? Okay, that's the note.
Okay, so you know what? The actual class, I really let them calculate manually the exercise on obtaining result for the Pearson correlation. But in this exercise that you're going to do, it's as simple as the last exercise because all you need to do is fill it in. It's already there in the file. The file I've already, yeah, haba ng formula, but it's just square. You square the x, you square the y, And then the final is that there's the ano, xy. So if it's beside each other, you just multiply. So anyway, I've already says forwarded to Prof. Nor the file for those who will be having difficulty in Excel. I mean in the Zoom. So okay. So for those who have good Zoom connectivity, ito na. No, that's the Google form and the file. The file. I don't know if Prof. Nor already given you the data set, but I'm giving it to you now here in the Google chat. Okay, you can now access the file and it's very easy because you just need to fill out. Okay, so everybody's done with the exercise. So let us have a look at this. Okay, so it is visible now to you. This exercise using Microsoft Excel in the computation of Pearson R correlation. There are so many statistical computations that you can do using Excel. So correlation is one, and in this particular data set, it's composed of just 62 cases. So we have here residents with codes 1, 2, and the age, the actual age, and then the sex, male, female, marital status. These are nominal level of measurements, no, for 6 number of children. So we have here the ratio variables that we can use in person correlation. The age, we have number of children, daily income, and there is mean level of awareness. This is already the mean that is being used here. So therefore, prior to this, there is another raw data wherein there are statements for level of awareness to which the mean of each of those are being put in here. So, guide person are to compute the R value for age by number of children. So the bivariate here is about age and number of children. Would like to know if there is a relationship between age and number of children. So that's why it's bivariate two variables. Place cursor at the cell for the mean result. So place cursor here for the age and children. Click formulas, more functions, statistical, correlation, that is correlation. For array 1, so there are two arrays, array 1 and array 2, because there are two variables. That's why we have two arrays. So higher up. So we can also do that by clicking here. And then correl, okay. Array 1. So it is B B2 to B63 because we know that there are how many 62 cases, and then everything is given here. So you just input E2 to E63. Done. And what is this? Why is the value?
Yung RA1 po, ma'am, B53 ang nailagay po sa formula. Dapat 63. B63.
B pala. Ay, wait, again. Ano itong namali ko? B2.
It should be B63.
63 and B2. Ay, nako, parang naguluhan si Microsoft Excel. Anong E? Ay, ano talagang mali ito ba? Ayo, B2 to B63. I know. Ay, ano ba yan? Number of children pala, E2. Ay, nako, E2 to E63. Wala na. Nalabad ng ulo aning kuan. Wait. Tama na ba no? Let us repeat. Okay. B2 to B63. Okay. E2 to E63.
Ay, alam mo ano. Dapat column. Yan.
So, okay. Okay. Ayan. Then this one, age by daily income. So, function for L, B2 to B63, and then the income is in F. So, F2 to F63. Yeah. And then the next is for level of awareness. So B2 to B63. And the level of awareness is in letter G. So G2 to G63. Yan. So based on this table for interpretation, with regards to age and number of children, there is 0.5. There is 0.5 here. So there is low correlation. Low correlation in all. Okay. Low correlation, but it's not saying there is no correlation. There is correlation, but it's just low. Okay. So we are done with correlation. And actually, wow, it's 11:57 now. There is still one topic here which is about teachers, but I will give to you the decision whether we are going to continue with teachers or not anymore. There are the video lecture for teachers is 11 minutes. And of course, there is a corresponding exercise which is like that. We just encode the easy exercise with the Excel file. So are we going to include teachers or not anymore? Teachers is you use the correlation. Usually you use that in your thesis. But teachers, you can also use that, especially if you would like to know if there is a difference between two groups of respondents, like male, female, or you may deal with two barangays, like barangay A and barangay B. If you'd like to compare the two sets of sample, but it's up to you. I don't mind. You want to extend to what? You may need 30 minutes for this because the 11 minutes and then you answer. But for those who are speeding, answering, device, human resource, and Excel resource, you may need only 15 minutes. What's your decision? You want to go teachers?
Okay. Yes, ma'am. Sure, ma'am. How about for others? For me,
Okay.
it's okay.
Okay, yeah, so Then we should not delay. T-test. Here you come, T-test. Sayang na po, you are here, di ba? And then this is the last time that you'll see me. Or I'll be with you to ano,
In this lesson on t-test, we are going to use in the computation the Microsoft Excel software. So the t-test function in Excel is used for calculating the probability of significant difference between two data sets, whether any or both of them are under the same population with the same mean. A t-test may be computed as a one-tailed distribution or two-tailed distribution with a kind of variance that may be equal or unequal. You remember I mentioned in that normal distribution, the 0.05 that you divide into 2, that will signify one tail or two tail. Now, the assumptions going back as a review again, that the variables in the involved variables in that particular data set are continuous, and the samples have been randomly drawn from the large data, and there is normal distribution. In some books, it's referred to as Gaussian distribution. Homoscedasticity or homogeneity of variance. Variance, you know, that is computed as one of the measures of dispersion that made use of mean. Okay, and it's very important here in t-test. Now, these things to remember is that the t-test can accept only numerical values. Anything other than numerical values, we get the result this morning in a cell in Excel. If the tails value is other than 1 or 2, because the tail value is just either 1 or 2. So we will also get this error, and the Excel will not continue the command that you are giving it. And of course, you should learn the difference between one-tail test and two-tail test to understand it better. So the standard p-value is 0.05 or 5%. If the variance is less than 5%, then your data is significant. So the t-test function in Excel, when you already have opened the Excel software, then on your screen, you have the sheets that is composed of rows and columns. And on top of that, there's the pull-down menu, wherein one of the headings is formulas. Now you click that formula and you'll be shown statistical, these choices. You choose statistical and you choose t-test. Now this will be how it looks. No? Specifically, okay, in this particular formula for the t-test, function in Excel is as follows. With these 4 arguments separated by a comma. Array 1, this is the first set of the sample you are testing. Array 2, this is the second set of the sample you are comparing. Tails, this is the number of tails for the distribution. There are 2 types of tails. One-tail distribution, and two-tail distribution. So you just put either 1 or 2 in here, and usually we use 2. And the type, you are going to choose either of the 3 types. There are 3 types of t-test available in statistics. Okay, this one, paired. This examines whether the mean between paired sets is equal. If you choose this second, sample equal variance examines whether the variance of means between 2 sets is equal or homoscedastic. And the third one, 2 sample unequal variance examines whether the variance of means between 2 sets is unequal. It is heteroscedastic. In recent versions, t-test is introduced. In earlier versions, t-test is the formula. Still, it is available in recent versions to support compatibility. So now, how to use t-test function in Excel? T-test function in Excel is very simple and easy to use. Let us understand the working of t-test in Excel by some examples. But I've mentioned these three we're going to do. Now, the functionality of the t-test can be explained best by using an example dataset to get the logic of the t-test. Here are Group 1 and Group 2 tests, scores of a classroom. So, of course, these are total of the tests given. We are to run t-tests to find if there is a significant difference between these two groups, especially if you are going to say you are going to compare the group to two groups or two sections, because there are two different teachers or there are differences in the approach in teaching, or there is a module used in one and there's no module in the other, something like that. So apply t-test to get the difference. The first test is a type of paired. So this is what you're going to do. This is in sequence now. After you have chosen t-test and then you are in this portion, you are going to choose paired. Now the result is 0.04059. Okay, the result of this t-test. So that is how fast. Sometimes you just blink and it's there. This is how fast. The second type, yes, of two samples is of equal variance. So you choose this one and the result is 0.2148. So there is really a difference. We are using the same data set, right? And that's the result. So the third test is a type of two sample t-tests. This one, the two sample unequal variance or heteroscedastic. The result is 0.2158. Okay, this one. So we have now this corresponding results. The return value is generally called as the p-value. If the p-value is less than 0.05, we can come to the conclusion that the two sets of data have a different mean. Otherwise, the two means are not significantly different from each other. Okay, have a look at that. This is the only one which is lower than 0.05, the paired. Now, okay. So in a closer look, the formula used, the paired, derive this p-value. The second, equal variance, this result, and the two sample unequal variance with this result. So as mentioned a while ago, if the p-value is below 0.05, then the conclusion is that the two sets of data have different mean. Otherwise, okay, the two means are not significantly different from each other. Okay. So we can run t-test using the analysis tool pack. At the same time, okay, what we did actually was based on the menu on above the screen of the sheet, right? So we can run the t-test also using the tool pack located under data ribbon tab, this one. So if you do not find this option in your Excel, follow the below steps to unhide these steps actually. So go to File and Options here. Click on Add-ins here. Then you're going to see this choices and you are going to choose Excel add-ins. go, and you have here these choices. You click on Analysis Toolpack, and you click OK, and voila, this must be enabled here in this portion. So when you click data, there is here data analysis. Okay. So if you click data analysis, you have these choices, and it will be easier when you are going to choose this mode of computation. So click on the first t-test, and it will open the below dialog box. This one, wherein you remember you can input the range, first range, second range, and here is the 0.05 value. Then where you want to put the output to place, in the new worksheet or in the same worksheet. It's for you to choose. Just click it and then OK. So, okay. So just choose the range like that. And okay, the mean of each dataset is shown. Their variance, number of observations, this one. Correlations, value. So once you do this, you are going to see all this. And the p-value, you refer to this one, B26, this one, the p-value, that's 0.0001861002. That is below the expected p-value of 0.05. As long as the p-value is less than 0.05, our data is significant. So this is the detailed report from what we did here. So, okay, we are done actually.
Okay, so I've already put in the chat box the dataset for t-test. Do you see the file and also the link for the form? So just
Wala
try
pa, ma'am.
and makita nyo?
Yes, ma'am. Visible na
Yes,
po.
ma'am. Yes, ma'am.
So you click on it and let's see how you do. Because again, it's very user-friendly file. I've already put in everything and you just follow the instruction. Even the instructions are there on the file and you just follow. Wrong. Napagod sila, answer pa sila. There are already 7 happiness T-test exercise, and except for one who got 3, so the rest have promising scores of 6, 7, 8, 9. There's 9, no? So that's a good start. Okay, and in fact, somebody already got 10/10. Huh? That's good. So just practice more for the one who got 3. Practice more because the one who got 5, because the rest have a score of 7 to 10. That's good. So it means that you just do what I did in the Excel files, and you'll be able to compute your own data set later when you have your thesis, and even with your data set in the office, so you can use what you've learned today and the previous session that we had. You can use them in the preparation of your report, no, wherein you can say, okay, there's a mean for your age, for your clients, so whatever you are dealing with, children or the 4Ps or what under the DSWD, various programs. Okay, so do you have any questions? The people here are busy right now prepping for lunch. But then if you have question, I can still answer you if you have.
Can we have your contact details for future consultation?
Just Marianne Duckland at msumane.edu.ph. So just separate my name. It's Marianne Duckland. And then just like your email. Do you have your IE? Because I think there are those who use their personal email, and so that's why I just click on the Google form option to not limit it to constituents. You cannot access if you are outsider. So I click on allow. So you can use even your Gmail or Yahoo Mail in accessing the forms. But okay, if you have IE, hindi na mo yung IE, no? Because the speed is bigger. But of course, when you're out of MSU, also say goodbye to all your files. So better use your personal email. So for personal email, just okay, social nurse 2009. I will inform you. Social nurse 2009 and gmail.com. That's what I use for personal purposes. thinking that, you know, when we say goodbye to MSU, we say bye-bye to everything else that we put inside in our email. So, okay, so that's my email where you can contact me. So if you have no questions now, because maybe you are more hungry than curious, so let's end this workshop webinar. And if Ma'am Nor is here and can do any, I can still access the video Zoom. Ma'am Nor, I'm turning it to you. Turning over the video, the Zoom.
Parang
Thank you so
nawala.
much, ma'am.
Thank you, ma'am.
Si Ma'am Nor
Parang
should,
nawala si ma'am.
yeah, kung
Dito si
wala
ma'am
na.
Norhaina
Andyan,
baka
andyan.
siguro may na
Ayan,
yung net.
andyan si Marawi na na. Okay.
Sige. While waiting for Ma'am to speak, o if she, hindi na siya makakaya, so ano na lang tayo, picture na lang, picture screenshot na lang tayo. I mean, please turn on your video, and this will be our last activity, the screenshot, and then let us, everybody's allowed to leave the Zoom. So you are all welcome. Okay. So nice meeting you here on Zoom, and then I'm now taking not yet. Anybody else who can turn on? Excuse na natin si Ma'am kasi masyadong mahina. Yan, si Shin.
Ang ganda ni Ma'am Shade.
Oh, di ba? Sir Ian, nandito naman siya kanina. Sige. Okay, let's take a screenshot in a count of 3. 1, 2, and 3. Smile. Yan, finish.
Thank you so much,
So,
ma'am.
thank you. That concludes our
With
mm,